Hello and welcome back to another episode of Let's Talk Security Testing, the podcast where we talk all things security testing. Today we're going to be focusing on a specific vulnerability. You may remember from a previous episode we highlighted logic flaws as something that we'd pulled out, discussed in more detail and explained, some of the nuances around that. Today we're going to focus on complex access control issues. Would help if I was able to say it, wouldn't it? Tom, what do we need to know about access control issues? What are they? Let's start super broad.
Access control issues they're an interesting class of vulnerability because they require a depth of understanding about what the application is actually supposed to do in order to identify them. It's really difficult to discern if something is an access control issue or intended functionality without first understanding deeply the resources that were intended to be made available to a user and the resources that were supposed to be restricted to that particular user or group of users.
So, come on, give me some practical examples. So, as a pen tester, what types of common ways do people build systems in a way where they can become vulnerable to this type of vulnerability class?
Sure. So, a classic is you build the API with the capability that you can be consumed by anybody who's authenticated, and then you assume that on the front end you can effectively just not make a button available to a person, right? And if you don't make the button available to the person, they've got nothing to click, and you might therefore believe that there's no way that they can consume that resource. But somebody who's able to enumerate that API endpoint exists is then able to call it and find that they're able to start doing things that maybe were intended for an administrative user or a different user. That's one side to access control issues. But another, and a really, really classic one that we see all of the time, is where you build a system where, for example, somebody can write a report or comment or something of that nature, and in that you've got an image. That image will probably be stored in an S3 bucket somewhere or some sort of storage solution outside of the database, where the database might have the controls that validate that the user's got the permissions to be able to fetch the resource. That image in that sort of dumb piece of hosting software probably doesn't have the same protections in place. So that means that you can start to pull down images maybe related to other users if they've got a predictable URL, predictable path, and start accessing sensitive data if there's screenshots that might include passports or driver's licenses or bank details, those things of that nature.
So when we typically, these vulnerabilities, a lot of people think that they are introduced at kind of like design phase or when a major release is done. You can understand it, right? When you're changing how a system thinks or how a particular user journey is structured, naturally there is a much bigger opportunity for these types of vulnerabilities to creep their way in, right? Because maybe you haven't threat modeled out the logic of what happens when a particular user is able to do this new journey and everything else. But, we see evidence on a daily basis of these things being introduced as a result of sometimes even minor changes. Can you give any examples of how these can be introduced, in a seemingly innocuous event rather than actually, the result of a major change?
Sure. Anytime you're introducing new back-end functionality and you're not fully considering the sort of who, what, when, where, why, and how of that situation occurring, and you're not putting the restrictions in place to limit who can access it and when they can access it, you can see these sorts of vulnerabilities rearing their head. So if I was to give you an example that we wrote a ticket a while ago where there was the requirement to introduce the ability to increase the permissions level in an application so users can promote other users to be administrators. And so we wrote the ticket that says that there needs to be the capability to have that. The developer picked that up and built that functionality. What we didn't say was that capability needed to be restricted so that only administrators can promote other people to be administrators. Now, that kind of a vulnerability, you can see how quite easily a developer has literally just followed the ticket and built what was supposed to be being built as far as they were concerned. And because we'd not really explored the restrictions around that functionality, it quite easily became what could have been a quite serious issue had it not have been caught during the testing process.
Totally makes sense, and it rings true. I was just reading a statistic this morning on OWASP's website that they're within their OWASP top 10. If the audience, I presume the audience is familiar with the OWASP top 10, but effectively ranks 10 classes of vulnerability, of which there are many CWEs contained within, and they list complex access issues as the most discovered. The group of CWEs that sit within there are the most discovered of any in that category. And I guess not necessarily a worrying statistic in itself, but I guess what might make it worrying is my next question, which is detection methods for this type of vulnerability. What's unique about the way we have to go about finding complex access issues?
Sure. So it's very, very hard to automate the process of detecting complex access control issues because it's very hard for a machine to understand what a user should and shouldn't be able to do. It's easy for me to show you an image of your passport and then an image of a stranger's passport, and for you to say, I shouldn't be able to access that stranger's passport just by going to this URL. But as far as the scanner is concerned, it's got two URLs and it's been able to fetch two images. It's not really able to distinguish what information is suitable to be exposed. And similarly, when you're calling an API endpoint or something of that nature, being able to even understand what that has done. If you get an OK response back, that OK response might mean that the system has done something that it wasn't supposed to for your user. It might mean that actually it's rejected you, but it's just returning a 200 OK because of the nuances of the way that application server's been configured. So you end up in a situation where the scanner cannot distinguish without maybe digging into another area of the application, the area where that function affects, to see whether or not that change has been made or not. And of course, scanners are generally dumb. They don't know what the functionality that they're calling is supposed to do and what it's not supposed to do, so they can't really do that level of digging. So that's a real challenge with the detection methods of scanning. Another challenge with detection, even with people, is that unless you know the functionality exists, it's very hard to be able to determine whether or not you can consume that information. So if, for example, you build some administrative functionality and your E2E tests or your user acceptance tests only cover other areas within the application, only cover like a standard user role, for example, or even your tests only cover the buttons that you can click within the application, then you might miss that API endpoint that can actually be consumed by your user. If I log into the application as a standard user account, I see 10 buttons on my screen. I think there are 10 things that I might be able to do. But if there is an API endpoint for that 11th thing, and I've just not got that button because it's not presented within the user interface, that access control issue could still exist, and I just wouldn't know about it. But a malicious person might enumerate the endpoint as that sort of standard user role and be able to find that vulnerability.
Yeah. No, it makes a lot of sense, and I guess this is why when we look at this automated testing technology, as good as it can be for certain classes of vulnerability, rules-based technology, techniques like fuzzing, they're looking for a system that's behaving abnormally, right? And what you're describing as these vulnerabilities often, to a system or even just to a person in some cases, might appear that the system is behaving normally. It's looking at the nuance of that data and what might be able to be either manipulated by an attacker, or simply, as you say, is just not retrieving the correct data.
Yeah, a perfect example of how difficult this kind of a decision-making process is for a person, let alone for a tool, is if I was to tell you now, I would like you to test this application and make sure that a user can't do what an administrator is supposed to be able to do. That is not enough information. You need to know what the application can do, right? And then you need to know what the administrator is supposed to be able to do. And those kinds of nuggets of information, you need a depth of understanding about the application that, even in a short-term penetration test, you might not get unless you've got that deep relationship with that customer to then start inferring, I'm starting to do things here that actually maybe this role isn't supposed to, and that just
Yeah.
gets even more complex when you're talking about dozens of user roles and sort of more granular permissions.
And I guess this isn't about these days. I mean, it's not just about understanding just how the system functions. You know, you can take a platform like X and say that, you know, I use X on a daily basis. I know how X works. I know where the buttons are. But when these things are all held together by microservices and APIs, actually truly understanding how this system operates might be a much more complex exercise than it traditionally was before we introduced all this additional complex architecture to these systems.
Yeah, you can agree more.
Cool. I guess moving on then, what can we do then if scanning technologies can't really find them and these things can be introduced even by a slight minor change? What types of techniques do we have at our disposal to be able to protect ourselves against complex access issues rearing their head?
Well, an easy automatable thing that I see work quite well, and this isn't a foolproof method, but is just simply introducing some smoke tests, some simple automated tests that you have defined yourself to be able to attempt to access certain resources that you know you shouldn't be able to access. You know, if you program in and say, if you can reach this file, you know that the permission system's become broken in some way, shape, or form. That's a really good smoke test. The next thing is just reviewing your tickets to make sure that they're of sufficient quality, that developers are actually being given the opportunity to build these permissions and these checks in. Like I say, define who, define what, define when, where, and how a user should be able to do something, so that the developer knows to actually build defensively and only permit when that series of expectations are met. And then if it comes down to testing and making sure your testing strategy covers the front end and the back end and is informed by the changes being made, so that you know if you're introducing a new piece of functionality or a new API endpoint, that endpoint is tested and that it is tested using the user groups that you know are available through your depth of knowledge with the application, and build that level of sort of sophistication into your testing pipeline so that you are always testing the various different edge cases.
Yeah, and what type of if we are going to bring in humans to do this type of testing, and whether that be kind of after smoke testing or whenever, how what types of people would be good at this, and is this a job for a classic pen tester? Should we be pen testing changes more frequently, or can people of various different skill sets pick these sorts of things up?
I think it varies, right? I think that there is testing the changes more frequently is beneficial, and it doesn't take a particularly sort of sophisticated skill set to be able to verify at a simple level that user A can't do user B's things. It does require being able to consume an API without the front end, so some technical knowledge is beneficial, but I think certainly access control issues are the kinds of things where somebody with a bit of imagination and a broad understanding of how to use tools like curl, for example, is probably enough. If you can interpret and you know how to navigate your way around an application through HTTP requests, you can manage to find the vulnerabilities. You just have to have the imagination and also the systematic approach to be able to say, test this condition, test that condition, test the variety of different means and ways that things can be consumed.
And how much of a trigger warning do we get from the changes themselves? In that kind of, is it more obvious in some cases where these things could be introduced, or is it just the case that kind of they can come from kind of any type of change in any part of the system?
Realistically, front-end changes are almost never going to introduce complex access control issues. They're introduced when you make a change either to user roles and user permissions, or they're introduced when you make a change to a functionality within the application itself, an API endpoint, for example, being deployed, or the logic that goes on behind clicking of a button. So certainly, being able to identify tickets that are associated with those kinds of changes, whether it's simply having a process where when you write the ticket you flag it with a label that says this affects this kind of functionality and therefore test for these things, or whether you're doing something more sophisticated where maybe you're using an actual process or a large language model or something to help do that threat modelling and help imagine that these issues might be rearing their head. The tickets are definitely the source of truth to be able to say this has the potential to introduce an access control issue, and then you've got probably for most businesses until the end of your sprint cycle to be able to identify them before they go live, before they end up in production.
Awesome. So by looking at the tickets, by looking at the change data, we can kind of hone in, I guess, onto some of the techniques that you outlined earlier around smoke testing, human testing, that sort of stuff. But really honing in on those areas when those things could actually exist. All makes sense to me. I guess just before we close out, what kind of closing words would you have around this issue, and what can businesses take away from this podcast?
I mean, I've said it a couple of times already. When writing tickets, there is so much value in defining who, what, when, where, why, and how something is intended to be consumed, and then feeding that information into your testing program so that they can validate that actually only on those conditions being met the outcomes are actually being realised. And that sort of working in unison where developers are fed the right information and testers are fed the same information is, I think, the way that you catch these kinds of issues that require context and understanding in order to be able to identify.
Awesome. Right, well, thanks for listening. Really good episode. I've really enjoyed this one. And we'll see you again in a couple of weeks. Bye now.